Hello everybody, welcome back to Arduino for Amateurs. This is episode number 19. We're going to be talking about I2C temperature sensors. So who am I and what am I talking about? As always, my name is Matt Gracie. I'm a hacker from Buffalo, New York. I'm a member of the bithaven Hackerspace. And what I'm going to be talking about in this video is adding another device to our I2C bus. You may recall in the last video, we used an LCD display, an LCD 1602, that was connected to our Arduino via I2C. And I said at the time, I2C being a controller target bus topology, where we have our Arduino and we're able to interact with multiple devices with multiple addresses at the same time. We could add more. So that's what we're going to do in this video. We're going to add a temperature and humidity sensor to our I2C bus. I2C, just to review, is inter-integrated circuit. It's a very, very common messaging protocol that's used both with microcontrollers like an Arduino and also used in things like motherboards or HDMI connections. So what we're going to do here is we're going to add another device to I2C. We're going to connect to it using the same sort of wiring. We'll see that in a minute. And then we'll interact with both devices at once. All right. So this is the temperature and humidity sensor that we're going to use. It's called an AHT20. I got a package of 4 of them off Amazon for a couple bucks. They are very small. They're sort of the size of a classic cell phone SIM card, if you remember those. Maybe 1/2 inch by 3/4 of an inch, right? Very small physical device. This top part, the part that you can see now, this is where the actual sensors are for temperature and humidity. You see there's 4 pinholes on the bottom here. We'll look at those again in a second. They also ship with a header. So what this is a device that you can solder in place if you're using this with a breadboard. You would put these 4 short pins into the 4 holes here and then put a little dab of solder on top of each one. I didn't do that, mostly because I don't have a decent soldering iron at home and I haven't been over to the Hackerspace in a little bit. But if you wanted to permanently attach the header, you could do that. What I'm doing for this video, for this walkthrough, is I'm just sort of resting it on there, and we'll see that in a minute. So you would put these 4 short pins into the holes, and then these 4 could be plugged into your breadboard. The reason they ship it this way is that sometimes you don't want to use it with a breadboard. Sometimes you want to solder it directly into another circuit or connect it to some other device. They want to give you sort of maximum flexibility to configure it how you want. This is the reverse side of that AHT20. As you can see, I'm sorry, it's a little blurry. My camera didn't focus very well, I guess. But as you can see, we've got 4 pins, and they're labeled voltage in, ground, SCL, and SDA. As you know from the last video, SCL is serial clock, SDA is serial data. These are the 2 connections that we need to connect it to our I2C bus. There is another very common humidity and temperature sensor. It's called a DHT11, I believe. I went with this one for a couple reasons, even though I already had a DHT11. Primarily because I wanted to do the I2C piece of this. I wanted to have 2 I2C devices on the bus concurrently and see how that works. And partially because these are significantly more accurate. From the reading that I've done online, I haven't tested this myself. The DHT can have a swing of a couple degrees centigrade in either direction, whereas these tend to be fairly accurate. All right. Another thing that I've added to my setup this week, I have a small stand that we printed on the 3D printers at the Hackerspace. So thank you, Defu, for helping me out with that. It's just a little plastic stand here. You can see there's kind of a wedge shape and a hole in it for an LCD 1602 display. You just put the LCD 1602 in place and put some M2.5 screws through the corners, some bolts, washers, and then nuts on the backside, and that holds it in place. This is the site, this is the page on Thingiverse where you can download the plans if you need to print one yourself. I think if you search for LCD 1602, this is the first one that actually comes up. This is what mine looks like. So when it's done printing, this is what you'll have. Little sort of picture frame style stand. You can see there's the bolt holes in the corners here, and then this is sized to hold an LCD 1602. When I put it together, this is what it looks like, right? So I've got sort of a nice little kind of desk stand, desk display for my LCD 1602. How does that connect in with the rest of the stuff that I'm doing today? All right, so looking in here, you can see I've got my LCD 1602 over here. I'm using the second one, the one that's got the I2C backpack on it. So I'm not using the 16-pin interface. I'm using the 4-pin interface. And those 4 pins you can see right here, I've got black for ground, red for power, green for, looks like SDA. Let me check my wiring here. Yep, green for SDA, and then yellow for serial clock. So those are going in here. If I want to concentrate a little more on the breadboard, that's the next slide. So we see here I've got green for SDA, yellow for serial clock, and I've got my power lines and my ground. There are 2 different power outputs being used here, the 5 volt and the 3.3. The reason for that is that the display requires, the LCD 1602 requires 5 volts of power. So I've got that plugged directly into the 5 volt line. The temperature sensor only requires 3.3. So I've got 3.3 plugged into my power rail here. And 5, you see, is going off screen here. That's going over to the LCD display. Ground is right here. That's connected to the ground rail. And over here in the corner, you can see there's the ground from the LCD coming back. And then here on my temperature sensor, I've got those 4 holes, right? I put that header into the breadboard and then set my sensor on top of it. I had to put a little piece of sort of scrap paper, scrap rubber underneath it to hold it steady, to make sure it maintained those electrical contacts. I wouldn't have to do that if I soldered it in place. I'll probably try to do that next time I'm over at the space where the good soldering gear is. But this should be good enough for today. I've got a power line coming in. You can see the red coming off the power rail and going to this connection right here through that set of tie points. I've got the black coming in from the ground rail that's connected here. And I've got yellow and green coming in from over here. So what we did here is we had SDA and SCL, and then those are coming off of the Arduino and connecting here to this row of tie points. So all of these yellow ones are SCL, all of these green ones are SDA. It comes off the Arduino and connects to the tie points here, and then I've got a green and a yellow going over to my LCD, and I've got a green and a yellow coming over here to my temperature sensor. So I guess the point that I'm trying to make is everything is sharing that same connection back to the SCL and SDA pins on the Arduino, because they're all connected to that same I2C bus, right? It's all kind of put together. All right, so let's take a look at our scanner and make sure everything is working the way we expect it to be. So this is our serial monitor. This is our scanner. You remember this code from last time. This does sort of the brute force of all the addresses to determine what I2C devices we have. I believe our LCD was OX27. So let's run the scanner and see what our temperature sensor is. We'll run upload, go back to our serial monitor, and there we go. So we've got OX27 and OX38. OX27 is our LCD, and remember we've got those jumpers on the back of it. If we want to connect multiple LCD panels, we can change the address using those jumpers. Unfortunately, for the AHT20, for the temperature and humidity sensor, there is no way to change the address. It's hard-coded to OX38, so you can only have one of this variety of sensor on your I2C bus. Not an issue for our particular scenario, but if you're trying to build something with multiple temperature sensors or multiple humidity sensors, you'd need to use a different one, maybe one of those DHT11s that I mentioned earlier. So the upside of that, though, is that every piece of software assumes that you're using OX38, so there's less configuration to do up front, so that's handy. But all right, so we've got our I2C scanner has run. It has identified our two devices. We've got OX27 and OX38. So we've already seen what the code to make 27 work looks like, and we'll get back to that in just a minute. But let's see what we need to do for OX38. I'm going to go over here, and I've got this code. I got this code from controllerstech.com. They have a tutorial on doing exactly this, interfacing an AHT20 with the Arduino. I'm going to walk through the code. One thing that I need to do is install the appropriate library. So right now, I do not have this AHTX0 library installed. So I will install that. It's going to ask me if I want to install some dependencies. This is other pieces of code that this particular library is dependent on. So I will install all. I'm feeling generous. That's probably going to use like an extra 3 bytes of disk space. All right, so everything is installed there. Everything is ready to go. So taking it from the top, the first thing I do, I include wire.h. Wire.h, you probably remember from the last video, that's our library for doing I2C communications. It's the protocol library that we're depending on. I also include Adafruit_AHTXO.h. That is the library for dealing with this temperature and humidity sensor. There are other libraries. There's one that's just called AHT20, I believe. You don't necessarily have to use the Adafruit one, but this is the one that I've been playing around with, so it's the one I'm using for the video. Okay, first thing we do, we create an Adafruit AHTX0 object. We'll call it AHT. Then we go into our setup. We begin our serial monitor, 9600 baud. We print to the serial monitor AHT20 sensor test. So we're just going to print that to the monitor. If it is unable to begin, that is, if the sensor is not responding, if there's a problem with my wiring, then it says could not find AHT20 sensor. Try it again. And if it does find it, it says sensor found successfully. This is super helpful because I don't mind admitting it took me a while to figure out exactly how to get all of the electrical contacts touching and set up the way that the Arduino could find the sensor reliably. So this is very, very helpful. I actually was struggling for a while because I could get the address from my I2C scanner, but I couldn't read data from it. And it turned out it was just a wiring issue. There wasn't electrical contact, but figuring that out was tough. So this sensor test was very helpful. I always say one of the fun things about Arduino is it gives you a good chance to fail at both electronics and programming at the same time. I can't tell you how often I spend time updating my code over and over and can't figure out why it won't connect, and then I realize that I forgot to connect a wire somewhere. All right, so that's our setup, and then we get into our loop, okay? So we create 2 sensor event constructs called humidity and temperature, and then using the AHT get event library, we pull in those readings. So we get a humidity reading and a temperature reading. Now to the serial monitor, first we print the temperature reading. So we print the word temperature space, then we print the value of temperature.temperature. Right, so we're basically taking a float, converting it to a double, and then we print space degrees centigrade or degrees Celsius. This next one, this I included. I did not get this from the website up above. This was my little modification. I added a conversion from Celsius to Fahrenheit because my brain is just wired that way. I expect the temperature to be in Fahrenheit. So print temperature, then print temperature.temperature times 1.8 plus 32, because that's the conversion formula, right? Multiply it by, is it 9/5 and add 32. And then print line degrees. F, degrees Fahrenheit. And then finally, print the relative humidity. So humidity space, then the value of humidity that we pulled from up here, and then percent. Then print a dashed line, and then delay 2 seconds and do it all again. So this is a pretty simple program, right? We use the built-in hardware temperature and humidity sensor to pull a temperature value and a humidity value, and then we print them to the serial monitor. So let's turn on our serial monitor and upload this. We'll clear this value. And there we go. Our sensor was found successfully. It is 20 degrees centigrade or about 68 degrees Fahrenheit here in my office with 37% humidity. You can see it's changing slightly by, hundredths of a degree here and there. Let me turn the auto scroll back on. Now, if I want to confirm that my sensor is working, what I'm going to do is I'm going to put my fingertip on the sensor for a few seconds, and we should see the temperature go up. Right, so right now it's still reading 68.43, 68.43. Now, there we go, 77.87. So, and apparently it's very humid under my fingertip. So, we do know that our sensor is working. We know that it is reacting to changes in the environment. I don't have, a heat gun or anything here, but I think that was a good, quick test. So we have our I2C temperature sensor working correctly. Now, the next thing that we want to do is combine our I2C temperature sensor with our I2C display. So let me bring back the code from that. Here was our hello world code that we used. Let me make sure that's on the screen, that we used when we were working on the last video. And then here is our temperature screen here. So let's sort of mash these together, right? Because we want to have the same input. We want to have the same temperature and humidity values, but rather than outputting them to the serial console, instead we want to output them to our LCD 1602. So let's include that. So we'll include liquid crystal I2C.h. Okay, so we've got that additional value there. Now we're going to copy this over to create the LCD object. And then in setup, let's comment out all our serial stuff here, because hopefully we won't need it. But I don't want to delete it just in case we do, if we start having trouble getting readings out of the sensor or whatever. And then we will add our LCD init stuff. All right, so our setup, we don't need to do any of this sensor test stuff, so that's commented out. We just need to initialize our LCD, so that is all set. All right, and then we'll keep this. We'll get our humidity and our temperature readings. We'll run our get event. And then instead of all this serial monitor stuff, and again, we can just copy that out, or comment that out rather. Let's print that to the LCD. So we'll do, copy this over. So on the first line, we want to LCD print temperature in Fahrenheit, because again, I am hardwired to understand Fahrenheit. And then we'll do an LCD.print and let's use our Fahrenheit formula here. All right, and then we'll go to the next line and we'll print humidity, and then we'll do LCD.print. Oh, we don't need the quotes. We'll print the value of humidity.relative humidity, same as we were printing to the serial monitor before. Okay. And then we'll follow that up with an LCD.println %, right? Because we want to have the percentage value there. All right, so what this should do is it should go to the first line of our LCD, print temp, paren, F, paren, colon, and then the temperature value converted into Fahrenheit. Then go to line 2, because again, 0, 1, we're going to column 0, row 1, and being good computer scientists, we start counting at 0, so row 1 is the second row of the display. Then we print humidity, colon, the value of humidity dot relative humidity, and then LCD print %. Then we will delay for 2000 and go back to the beginning, take our readings again, update the display. All right, so hopefully that all makes sense. Let me run my verifier here. Okay, looks like everything compiles properly. Let me upload it. All right. And looking at my display over here. All right. Looks like we are in good shape. And I know it's hard to see the display on the webcam when I just hold it up to the screen like this. So I ran this earlier and I took a picture. And this is what it ends up looking like. I've got my little desk display here, and it's reading out the temperature in Fahrenheit and then the humidity. Right? It's a little warmer in here then, I guess. This is just an artifact from the camera. It displays fine. Just kind of hard to get the camera to focus on something that bright. So that's all there is to it. I've got 2 I2C devices. One is a temperature sensor, a thermometer, one and a humidity sensor, and then the other one is my LCD panel. I'm reading the environmental information from one, the temperature and the humidity. I'm converting the temperature to Fahrenheit, and then I'm pushing it all out to my little desk display. Right? So now I can keep this on my desk, and I'll always know how warm it is in my office. One thing I would like to do, though, is add a timestamp to this. Right? The humidity is not as useful to me as having the date and time would be. Now, fortunately, there's another I2C device called an RTC, a real-time clock module, and I can use that to maintain a timer and keep track of the time and the date. So in the next video, I'm going to do that. We'll add a third device to our I2C bus, a real-time clock module, and then we'll use that to update our little desk display here. Okay? Thank you so much. I hope this was helpful, and I'll see you in the next video.